Okay, good morning everybody. Good morning. So I'm going to speak about the mathematics and theoretical computer science groups at IMSC during the last 10 years. So since I have about 15 minutes, I'll speak fast. So what I plan to do is to say something about each of the groups, the research interests of the groups, and then I'll say something about the doctoral programs, and then I'll say something about our publication record and also about our seminar and colloquium programs. Okay, so I belong to the mathematics group at IMSC. Our current faculty strength is 16, and this slide describes the research areas that we are interested in. So it covers a fairly wide swath of mathematics: algebra, algebraic geometry, number theory, functional analysis, representation theory, topology, geometry, and mathematical physics. So the names in blue represent the people who have joined us during this period, during this last 10 years. The names in red represent people who have left, either have retired or have moved to other places. And each of these things, each of the areas lists the people with those corresponding research interests. Okay, this is about the mathematics group. The TCS group has a faculty strength of 8, and here the main areas of interest are computational complexity, algorithms, data. Yes. Now, before getting into the actual details of the research carried out by these groups, I want to spend some time on the doctoral programs in mathematics and TCS. So we offer both the PhD and integrated PhD programs in both these disciplines. The PhD programs are meant for people with a master's background, and the integrated for those who have a bachelor's degree, motivated students with a bachelor's degree. The selection process is a two-level process. It goes through a national level exam such as the NBHM for the mathematics and the joint entrance test for the computer science students, and this is followed by an interview. The national level exams are used as screening, and then the interview is the final deciding factor before we offer admission. So I'll just flash some data of the number of students we've had over the last 10 years. So this is the data for each year. The number varies highly from 4 to 18. So this depends on how many students we get, and sometimes when we offer, people might choose to go elsewhere, so there's a large variation in the number. But approximately it's about 10 students per year, roughly. And this is for the integrated and PhD programs put together. Okay. So this is one of our one of the main things we do. So as a contribution to manpower development, scientific manpower development in the country, this is one of our main activities. So as a measure of success, so I would like to say something about the placement of some of our graduates. Initially I thought I'll give a long list, but I think considering that we won't have much time, let me just say the following. So most of those who get PhDs from here are placed either in the IITs or in ICERs or ISIs, CMI, NICER, many other universities. Some take up postdoc positions in universities in India and abroad as a first step before going on to faculty positions. And a very small number of them, well, maybe not very small, a small number of them also go to industry. Most of the students here go for academic positions. Okay, so the next thing I want to talk about is our research output in terms of publications. This is a rather dry slide. This is just the number of publications. I'm not sure how useful this is in evaluating any kind of research program, but nevertheless I thought I should say what it is. What I would like to focus on, however, is a more interesting thing is the research output measured in terms of books. So I want to list some of the books that faculty members here have written or edited, and there's a fairly long list of these, as you can see. Many of these books, some of these are conference proceedings, many of these are in fact based on the courses that were given here. So for instance, this book on measure and probability or the book on representation theory, all of these books came out from courses given here and which were later written up as books. So published by reputed publishers. Okay. Now I want to say something about the research contributions in mathematics and TCS, but since obviously I can't cover too much ground, I have just focused on one contribution in mathematics and one sub area in theoretical computer science. So let me just say something about this. So the area I've chosen is algebra, and within algebra the sub area of Lie algebras, and in particular the theory of Kac-Moody algebras, which are infinite dimensional Lie algebras. So simple Lie algebras, which are classified by something called Dynkin diagrams. I made a list of these Dynkin diagrams here. They come in 4 kinds called A, B, C, D, and then there are 5 others which are individual ones. These 4 are series: A, N, B, N, C, N, and D, N. That is an infinite list of each. And then there are 5 exceptional ones, the exceptional Lie algebras. So this is a classification theorem for Lie algebras. The area began in the late 1800s, so it's about 150 years old, fairly an old area, and the research in Lie algebras is still going on. So associated to a Lie algebra are mathematical objects called representations, and these representations have a kind of multiplication. You can multiply them in a certain way to form other representations. So you can think of representations in some way as analogues of numbers which can be multiplied, and this analogy goes to some extent. Among the representations there are some distinguished ones, which are the irreducible representations, and these should be considered as analog of prime numbers. The reason that these could be considered as analogues of prime numbers is because of a beautiful theorem, and this theorem says that if you have representations V1 to Vn and W1 to Wm, irreducible representations, and if after multiplying them they are equal, then it must be that the numbers must be the same, n and m must be the same, and the w's are a permutation of the v's. This is essentially very close to what you would do for the unique factorization of integers. So irreducible representations of simple Lie algebras have this unique factorization property. And in work that was done here, my colleague Vishwanath along with his student Venkatesh proved that a similar statement holds for these infinite dimensional Lie algebras called the Kac-Moody algebras. This is not a precise statement. There are some various kinds of conditions. So this Kac-Moody algebras have to be of a particular kind, but roughly speaking a similar statement holds. Now this might just seem like some generalization for generalization's sake, but it's not. That's not the thing. It's not. The interesting thing about the statement is not that it holds for Kac-Moody algebras, but the method of proof. The initial proof of this theorem was quite long and complicated, whereas the theorem of Vishwanath and Venkatesh, the proof is much simpler and holds in much greater generality. So, okay, I said something about special cases here, but let me just skip this. I'll just say that the proof depends on properties of the formal logarithm function. It's a beautiful application. So that's all I'm going to say about research contributions in mathematics. Let me go to research contributions in theoretical computer science. So here the area that I'm focusing on is a branch of complexity theory called parametrized complexity. So I'll say a few words about complexity theory. So the goal of complexity theory is to classify various computational problems according to their inherent difficulty, so measured, quantified in some way, and relate these various classes to each other. Now a basic dichotomy in computational problems is between those that can be solved in polynomial time and those that can't, right? The polynomial time is in the size of the input. So this dichotomy is very fundamental to theoretical computer science as such. For example, if you want to sort a list of n things, then it's easy to see that you can do it in polynomial time. In n squared time you can do it, or even better actually, but n squared time is the most obvious thing you would do, will do it in n squared time. Whereas a problem called the Boolean satisfiability problem, SAT, this is believed not to be solvable in polynomial time. So there is this polynomial time versus probably not polynomial time. Now this is just classical complexity theory. Parametrized complexity deals with the following thing. So it begins with the following observation, and that is that even in problems which are difficult to solve, which may require exponential time, they sometimes have small parameters, and these small parameters, the complexity is exponential perhaps in these, but nevertheless it is enough to allow for feasible computation. You can actually solve these problems fast, even though theoretically they are difficult to solve because of exponential complexity. So this is the rough idea of parametrized complexity, and a fundamental definition here is that of the class of fixed parameter tractable problems, FPT problems, where the complexity is of a certain kind. It dissociates into two parts. One is a function of this parameter k, and another is the power of n. That's an error over there. That should be n power something, n power order 1. So FPT problems are a special class of problems that are particularly easy in this sense. Now, IMSE contributions to parameterized complexity theory over the past 10 years include various things. I'll just read it out. Fast FPT algorithms for some specific problems, and above guarantee parametrization, where the parameter is not something that you might normally expect, but it's the distance to a good solution. Linear time FPT algorithms for some problems, and meta theorems. So these convert FPT algorithms to fast exact exponential time algorithms. So all of these things have been contributions from IMSE over the past 10 years. So next I'd like to say something about our conferences and visitor program. So in the past decade we have organized more than 80 conferences or workshops. These are the high level conferences or workshops. I'm not talking about our outreach program, which will be covered later, and these have been organized. Rather than say list them again, I'll just talk about one of them to give you an idea of what is going on here. So this conference was organized in 2014. It's a master class in the modular theory of one-Neumann algebras. And for this conference we had two visitors, very famous operator algebraists, Masamichi Takesaki and Serban Stratila. They were here for 2 weeks and each gave a course of 10 lectures. People from all over India came for these things, both students and research mathematicians for these. This is a very successful program that we had. That's just to give you an idea of the kind of conferences here. Okay. The other thing I want to talk about is our PDF program. So we have a large number of postdoctoral fellows at any point of time, and this is data on a number of PDFs for mathematics and TCS. And this is also one way in which we help in capacity building. So they interact with us and they also learn things, we also learn things from them, and this is one of the good programs that we have. And we have a YouTube channel. So this YouTube channel has about 4,000 subscribers at the moment and more than 400,000 views. So this is roughly 5 years old at this point of time, and many of our lectures, conferences, talks, many of these things are recorded and uploaded onto this YouTube channel. Okay. So let me conclude by mentioning some of the awards and honors that the faculty have got here. So this Lifetime Achievement Award of DAE from the PM for Balu, J.C. Bose Fellowships for Balu and Sundar, Fellowships and Associateships of various science academies and of ICTP for many of the faculty members, the Young Scientist Medal of INSA and the Nasi Scopus Young Scientist Award for Parthsadi Chakrabarti and Amritanshu Prasad, the SERB Women's Excellence Award for Shauli Gun, the Swarna Jayanti Fellowships of DST for again Amritanshu and Parthsadi. This ERC grant is a European Research Council grant. This is a major grant of some 1.7 million euros. This is for Saket for his parametrized complexity project. Distinguished Faculty Award of HBNI and Distinguished Alumnus Award of IIT Madras for Sundar. And last, this BM Birla Prize, which is very recently our newest faculty member Dishant Panchali got this. So I think I'll stop at this point. Thank you.
Let me begin by saying that thank you very much. It's an honor to be able to tell you about the contributions of the physics and the computer science group, computational biology group. I'll be reporting on the work of 28 faculty members and their students and postdocs, and I'm grateful to the faculty for providing me all the details that in such a short notice. and I'm basically going to give a collated summary of what was provided without specifications on name, giving you a feeling of the breadth of activity here and the techniques used for a large part. I'm going to be reporting on the work of several of the people who are experts, international experts, and I cannot do justice to the technical content in such a talk. So I apologize. I'm basically going to cover only the important aspects leading to techniques and things. Okay, there is 26 faculty members in physics, and 2 of them are also wearing the hat on computational biology, and altogether there are 4 in computational biology, and they have had a program for the last 4 years for graduate studies. The physics program has been running for many years, and the physics program is divided into 2 subcategories, the LEP and HEP, and there are different areas of activity in LEP and HEP, and currently the strength of each stands at 13. And 2 of the LEP members also are working in computational biology. So in statistical mechanics, we are interested in ordering in nonlinear systems, coarsening dynamics, elastic collisions, and the techniques are large-scale event-driven simulations, and also in macroscopic order active matter of things where large Monte Carlo simulations are done. So the techniques are numerical simulations. Again, we do critical phenomena, which is topological defects, phase transitions, and these applications in superfluid superconductors. They say again the techniques are large scale Monte Carlo simulations, and understanding entropy driven phase transitions, where partly analytic methods coupled with Monte Carlo simulations are used to deal with extremely high densities. There is stress in structure formation, relationship between mechanical stress and microstructure, for example bone. I think these also are based on elastic models in collaboration with experiments they are done, and we also use this in glassy solids and amorphous solids, where again large scale molecular dynamic simulations are done. And similarly, we have this failure process in mode of fracture, nucleation and percolation of damages. Again, this is based on large analytic and numerical simulations. We have very good computing facility where people are using these techniques, and the publication record was not provided here in detail, but publications are done in excellent journals, all top and international well recognized activities going on. The chaos, and again here partly numerical solutions of coupled nonlinear differential equations and coupled map lattices are done. Okay, jam matter properties, where we are trying to understand the structural inhomogeneities, colloidal gels, aging dynamics, confinement size and non-Brownian suspensions, and other properties. And again, there is based on large-scale molecular dynamic simulations, numerical solutions of coupled equations of motion of particles and fluids. Okay. There is nonlinear dynamics and complex systems, where the interest is in networks and pattern formation, complex spatiotemporal patterns, coevolution, prosthetic systems, and again the numerical solution differential equations and Monte Carlo simulations is a technique. So it's one of the, I would say, one of the very best groups in such techniques is here at Math Science. Then model of socioeconomic patterns, where universal patterns and interacting agents in economics and social phenomena are done, and again it's data-driven modeling of financial markets, emergent dynamics of popularity and things like that are studied. There is a computational soft condensed matter, where disordered vertices, phase behavior, disordered dynamics of solids and disordered background is studied. So these are examples, vortex, glass phases, things. Again, the techniques are analytic and simulation coupled to experiments. There is polymers. So the idea is to understand the thermal fluctuations, the shape of vessels, collapse phases, aggregation and highly charged polymers, and the applications are very interesting. The techniques again are analytic methods, Monte Carlo simulations, large scale coarse grained molecular divergent simulations, and there is a study of membranes, water and fluctuations, the understanding of interaction of polymers with cell membranes, water and the influence of ions, unfolding forces and things. Again, there is a large scale atomistic molecular dynamic simulations which are very interesting and have led to. There is also a group that does quantum condensed dynamics, where it's largely analytic work. There are 4 faculty members here. They have listed the members here, and since 2009 they have had 5 PhD students. There is currently postdocs in various places in India and abroad, IISc, HRI, Max Planck, Dresden, yes, Korea. There are 5 postdoctoral periods, postdoctoral fellows in the same period. Currently they have 4 students and 1 postdoc, and total publications 36. 8 of them are physical review letters. The activity is in frustrated magnets and spins, and in real materials, correlated systems and superconductivity, and this group also has activity that is covered by media. There is quantum geometry and topology, and the method development of many body systems using the idea of entanglement and developing non-perturbative approach to 2-dimensional Hubbard model. Things. Oops. Yeah. Okay. A partial list of the students and things, so I didn't put it forward, but as you can see, a large number of students have graduated in the group, and they have been postdocs at different places, and it's a very successful group. There are several conferences held. I have just given a sample of few of the posters that were provided, and there's also artificial intelligence, machine learning and vision inference. All these are this is applied, for example, to Markov chains to quantify the information, and it's published and covered a lot in press, applied to the index script thing, spatiotemporal point process to analyze growth and decline of Indus Valley urbanization. This also got a lot of coverage. Of course, such things do. There was a deep learning pipeline developed for automatically recognize Indus Valley characters, and this has also got coverage in media. There's study in fluid dynamics, where the publication record is very nice, and it has also got covered in press, and a startup company was formed which has contracts from several things, and some of our ex-students have joined this. The patents are pending. Since I have very little time, I am going to move fast and not give too much detail. In in optics and quantum information, we have 2 faculty members. One has joined in 2015, and Professor Shibashish Ghosh has been here for since 2006. Professor Simon is currently a SERB Distinguished Fellow, and they currently have 5 PhD students and 4 postdocs. 6 students have obtained PhD, 2 are faculty members at IIST Trivandrum and IISER Mohali, 4 postdocs who are currently in Belgium, IIT Madras as faculty positions, and they have a very successful thing. They have about 50 publications in spite of few faculty members and 15 preprints. The work is on simulation of various quantum mechanical properties with particular emphasis to quantum field theory. For example, this applied to neutron oscillations, There is a quantum information theory to classical apply quantum information system apply in classical polarization optics, and this also has been published in very high journals. So this is only a sample of what is being done, and quantum information system and dynamics of open quantum systems in quantum thermodynamics. This is also. Now I get to the high energy physics part of it. I hope I am on time, and one of the dominant groups here is string theory. 5 faculty members: Sujay Ashok, Partha Mukhopadhyay, Kalyan Rama, Balachandra Satyapalan, and Nimani Suryanarayana. Since 2009, they have 7 students have obtained PhD in the string group. They are currently postdocs at various places in and outside India: TIFR, ICTS, Weizmann, Johannesburg, Torino, and 7 postdoctoral periods is the same. 7 postdoctoral fellows is the same period. Many of them are faculties in IIT, etc. Now, currently they have 11 students working towards the PhD. They've arranged several conferences, and 3 of them I include here. And the work is basically in several areas: ADS, CFT correspondence, so holography. Holography is one of the biggest ideas to come out of string theory. The duality between boundary CFT and gravity string theory in higher dimensional ADS space-time. And then there's activity on black hole and cosmology. So understanding the singularities of horizon of black holes remains a challenge in quantum gravity. Quantitative analysis of possible dynamics inside the black hole is also been studied here. There's activity in quantum loop cosmology, where the model of singularity-free cosmological evolution of the universe is constructed. This model can be used to study a variety of non-singular evolutions of our universe. And then there is supersymmetric gauge theory generalities. Gauge theories describe all known forces except gravity. Non-perturbative formulation of this is unknown, and so hopefully by studying duality you will be able to extrapolate lessons from such phenomena, actual phenomena. Okay, there is also background independent string quantization. String quantization is not understood in general for arbitrary curved space-time. In the problem of background independence, a specific mechanism has been proposed in finding a certain geometrical feature which is infinite dimensional curved space called loop space, and the applications would be understanding the bound states related to the behavior of quantum mechanics and gravity. Okay, there's a group on astrophysics and gravity. There are 2 faculty members. Manjari joined only a few years back, and they have 5 students who have completed, 3 are ongoing, 8 postdocs in the past and 3 in the present. I'm covering only the last 10 years in all the groups. So low frequency gravitational waves, activity in that. There is theoretical and observational aspects of pulsars, and studying mysterious fast radio bursts, GMRT, Putty Radio Telescope, AstroSat, and the 11 publications, the present faculty, and 4 with students with other people. There is also a book published. I don't have a compilation of all the books. There are several proceedings that have been published from IMSC, but I don't have a summary of that. Then I get to the HEP phenomenology group, which is another big group, which is works basically on standard model and beyond. There are 5 faculty members: Indumati, Shri Gopalakrishna, Ravindran, Neeta Sinha, Rahul Sinha, and 2 emeritus faculty who are also active in the group. We have 10 students who have obtained PhDs in phenomenology and 3 on INO. There are currently faculty as BITS, DU, postdocs at various places in and outside India: HRI, ISCS, John Korea, NTU, DAISY, Germany, Culture, such places. Currently there are 12 students and 1 postdoctoral fellow, 90 published papers, and 42 proceeding preprints. There have been plenary speakers and organizers at various leading international and national conferences. And so I'll cover neutron physics, which of course we have established neutron oscillations. So one of the activity, as you are aware, is the ENO. IMSC has done significant contribution in that. The interesting question of whether neutrinos can be its own antiparticle is if they are Majorana. It was shown that this can be studied in decay modes of mesons and tau leptons at colliders, and then the neutrino factory studies with due tau interaction in detectors will result in charged tau leptons, which will contribute to the background. As background had been missed earlier, the effect of this contribution of precision measurements is studied, and this was then asked as a contribution to the international development studies of neutrino factories, and IMSC made a contribution to the international proposal. There is QCD physics at LHC. Quantum chromodynamics, as we know, plays a very important role at LHC. Precise prediction based on perturbative QCD is important. One has to test standard model to a good accuracy, and you need to get deviations of physics to set bounds of this, and QCD corrections are of course critical. So one of the leaders is here, and what has been done recently is a major achievement of 3-loop QCD results for Higgs and Brillouin, unraveled the universal structure of soft gluon effects, and they can be applied to processes, Brillouin, Higgs processes, cryptocrying graviton production, etc. And the universal soft distribution function is obtained using, and can the idea has been used to apply to Brillouin processes, Higgs production, pseudoscalar Higgs production, associated Higgs production, and rapidity distributions of the various things. This is a very significant achievement which has been very well recognized internationally, and of course the 2 PRLs recently that were published on this with students here. There's of course a study on QC fragmentation functions, because the idea is that quark okay. So we have got a study of fragmentation functions beyond the standard model physics, where we have studied charm, chiral coupling of W and top, and then vector-like fermions and Higgs physics. So several of these studies are done. Then we had probing symmetries via Dallas plots, where we were able to show how to test fundamental properties like Bose symmetry, CP, CPT, and SU3 flavor symmetries, and this got covered in international conferences, the PRL publication and things. And then we have searched for new physics at B2K star LL. It is one of the most important modes studied at LHC. It's often called a hot topic because of the continuing existence of anomalies in this indicating evidence of new physics. We were the first in the world to study this mode in 96 and 99, and then started studying this mode again at this institute in 2010. LHCb in one of the press conferences released a statement that the angular observables are highly sensitive to efforts on new particles of the decay. The decay B2K star is a laboratory of its own, said Patrick Koppenberg, who is LHCb physics coordinator. Many of the particles that certain experiments search in this data can be studied in this decay. And the IMSC current approach makes no hadronic assumptions, however innocuous. This approach is receiving attention as the most viable way to search for new physics using heavy meson decays. So recently the group showed that there's evidence of right-handed currents at pi sigma. Weak interaction of quarks and leptons. The standard model is all left-handed. That is Sudarshan Marshall, left-handed current, Feynman-Gallman. So we have showed that there is a right-handed current, and we have proved the existence of new physics with similar significance in other proposal. Recently the group showed the explanation of lepton non-universality anomalies in B decays. So also PRL just proofs of that are here. And then there is activity in Bell and Bell 2, where a lot of work developed here at IMSC is being studied at Bell and Bell 2 detectors, and IMSC was cited in the Nobel Prize poster. Lattice QCD, one faculty member, and one more is going to expect to join soon. 13 journal publications, 50 proceedings, and one student to finish soon. 2 of the previous postdocs are at Dubna. And then I quickly get to computational biology. IMSC has a traditional support for interdisciplinary work, group creation, a direct outcome of the 2009 Institute review. A PhD program approved by JBNI Life Sciences Board of Studies in 2012, and that's why there are 4 years of graduate study going on. And currently there are four faculty members. One more is involved in teaching several visiting faculty who come to the institute. There's a regular PhD program. Currently there are 4 batches, 14 students and 1 postdoctoral fellow. Few Indian institutions exist with strong theoretical biology base. The idea is to develop and emphasize the relationship of biology with other sciences and mathematics. Emphasize the interface of biology with mathematics, physics, computer science, and statistics. Computation is a tool for realizing this. Also, the importance of understanding experiments. So they have regularly organized meetings, and the research activities are genome dynamics, biophysics, systems and network biology, ecological modeling, cancer research, computational neuroscience, infectious disease modeling, biomolecular simulations, and they have got a lot of press coverage already in their activity, and very remarkable. They have arranged several meetings, and these are just a sample of that. Thank you very much for your kind attention. I'm sorry I exceeded time. Thanks.
What I'll discuss here very briefly is a bunch of project proposals that we've made to the DA and how they constitute our vision for the future and where the institute is going. So there are 2 rough divisions. First, the proposals deal with strengthening current research impact in the institute, and the second, they deal with emerging areas where we are not completely involved in yet, but in which we would like to be a part because we see them as being important to the future. Under strengthening research impact, there are roughly 4 main categories. First is to raise IMSC's research profile overall. What is it that we need to do to become more acknowledged, more known, more impactful in the wider world of science outside? And certainly this will involve funding and having international meetings, workshops, an active visitor program, and doing more outreach to ensure that more students are attracted into science and mathematics. The other part that I'll spend a little more time talking about is emerging areas. And here what we want to do is to strengthen collaboration between institutions, look at national priorities and examine how IMSC can contribute to these priorities, build capacity, because again this is important for our country at this time, and then look at what it is that IMSC can specifically do, what are IMSC's strengths in the way in which we can contribute to the wider landscape of science in the country. So when we look at strengthening research impacts, certainly one way to do it would be to do targeted hiring. For example, in subjects like information science, interactions in topology, in condensed matter physics, in fluids, in cryptography, material science, etc. All of what we plan to do, most of what we do now as well as what we plan for the future, needs high performance computation. And this is really the backbone to our future and current work. We'd like to encourage and have more experimental collaborations, meetings, instructional schools, outreach, etc., etc. And in general, internationalize our work further as far as we can. What I spend a little more time on is these new directions, and I've chosen out of a bunch of proposals that were submitted, about 6 or 7 of them, about 7 of them over here, and I spend about a slide and a half on each one of these to tell you what is special about these subjects in our context and what it is that we think we can do. So the first is the Virtual Center for Quantum Information. So quantum information, quantum computing, quantum communication, these are all fields that everyone agrees are crucial and important for the future. There is a lot of interest from DST in initiating a national effort in quantum information, part of which are communication, cryptography, etc., etc. There is interest also from defense in how one can communicate over a large scale in a sufficiently secure manner. And some of this is because of China's recent effort in looking at action at a distance, in particular across space, between Earth and a satellite. There are many reasons why IMSC is a leader in the country at this point. There are several high-profile international training schools and workshops that we've held here in the past. We've trained students and postdocs, and as Rahul Sinha mentioned, many of these are now at multiple institutions, both in India and abroad. The group is respected. It has fairly high impact in this research in this field in the country. So here are just some of the conferences that have been organized, 2013, 2014. So organizing conferences, meetings, workshops has been an important part of what this group has done so far. The second proposal is a proposal for a virtual center for the modeling of materials. And of course, the interest in material science is how do you make a material that does what you want it to do, not what it wants to do. So how do you incorporate the right designer properties so that they can be switched
by the addition of appropriate fields? Can you think of materials that are useful substrates for quantum computing? For example, the creation of the right sort of qubit in a superconducting system. And then soft matter, which itself is a huge separate field with large number of industrial applications. So there is, as Rahul has pointed out, there's a strong quantum antibody theory group with interest in correlated topological materials, with several high-profile papers in the last 5 to 10 years. And there's also a strong computational soft matter group. Again, Rahul alluded to some of this in thinking about fluids. They set up a company. But this is again, there are also many national and international collaborations, and there's a strong interest in working with industry in this particular group. So that's one overlap that could potentially be developed in the next 5 to 10 years. Radio pulsars and fundamental physics. This comes from the interest of, I think, our almost newest faculty member, Manjari Bagchi, who has been working on pulsars and pulsar astronomy for a while. And these are interesting new systems to look at gravitational waves in different contexts and explore the fundamental physics of gravitation and other astrophysical processes in a different way, using signals from pulsars, which are very accurate clocks. And there is IMSC involvement in terms of proposals to the pulsar timing array and GMRT proposals and involvement in GMRT pulsar search. And the idea was to look at subtle general relativistic effects in neutron star binary, neutron star black hole binary. So this is different from LIGO, but could potentially address some of these questions from a different sort of angle, and also including the study of translational pulsars. This is an interesting proposal because it's an experimental area where a theoretical institute such as ours is strongly involved in, and ultimately the analysis must be a close combination of theory and experiment going in together. Computational systems toxicology is another interesting area. This comes from the computational biology group. Of course, we are surrounded by various types of chemicals. The effects of these chemicals on the human body is not particularly well characterized. So the question is, how do you assess the risk of environmental chemicals that you encounter? So there are more than 8,000 chemicals which have been commercialized today, but we know relatively little about the toxicity, the potential toxicity of these. And to do this, you have to understand how chemicals interact with the body, with the metabolic networks inside the body. So you need very specific expertise for this. You need to understand systems biology for metabolic processes and use this. And this is an area where Arijit Samar, who proposed this, has been working in looking at constraint-based metabolic modeling of toxicogenomic data, and especially endocrine disruptors. So for more than 650 disruptors which have been identified, you can look at the entire sequence of how chemicals affect genes, how genes affect diseases, etc., completing the full circle of how the chemistry of these compounds interacts with the body, with metabolic networks inside the body, leading then to disease. And so this involves classical tools of network analysis and flux balance, which there is a lot of expertise in the country. This is a proposal from Shitabha Sinha and group, which is the Center for Econophysics and Data Science. Complex social systems surround us, and certainly this is one example of the contacts between people and the transmission of SARS in Hong Kong. And you can see that this has the structure of a fairly complex network. This reflects the interactions of people, the social interactions and connections between people. And this is one example of how a network analysis of structures like this can tell you a little bit about how diseases might propagate. So you can apply these ideas in multiple contexts. For example, looking at social economic activity, where you analyze big data to look at this. And the biggest data of all are typically generated from trading data at the stock exchanges, because there you have interactions happening over the time scale of fractions of a second. And then you can ask, what happens to the market? What are the large scale shifts in the market? Are they precursors to markets crashing? And these are really questions on how do you analyze complex time series, complex networks in many ways. And in that sense, these are general questions that apply to all of large data. So there's certainly natural importance for big data. We are a big country, we generate a lot of data, and to understand it and make sense of it are all questions that fall under the purview of big data analysis. So IMSC brings a lot of expertise in network science and social network modeling, and certainly is one of the prominent Indian groups in this area. We've already looked at, Shtabha has already looked at state-level economic infrastructural data analysis for looking at businesses and how they might invest in different parts of the state, as well as looked at 3 decades of data from the Cancer Institute to look at how to repurpose drugs for cancer treatment. And so the idea is to have a small handheld device that you can put in patient details, and that will tell you what is the medication that might be most appropriate to, based on machine learning applied to about 3 decades of data on patients collected by the Cancer Institute. The last is this IMSC Center for Infectious Disease Modeling. Again, this is an interest of the CompBio group, and the reason for such a center is that there's very little, by very little I mean virtually none, high quality model based input to health policies and disease outbreak response in this country. We are a country with many diseases, many what are called neglected tropical diseases. Those of you who've been learning about Japanese encephalitis outbreak in eastern UP and Bihar will know that we often do not have an idea of what is causing these, how they spread, what is the underlying mechanics of the disease. These are all questions. There's a lot of interest from government in supporting modeling for health and disease because this is viewed as being a really neglected part. What we would like to do is to build capacity for this modeling. We believe that we can do that uniquely here. In terms possibly of an international PhD and postdoc program that DBT and ICMR would be willing to support and have already shown considerable interest in. So currently we work with multiple collaborators on public health questions. For example, the CMC Vellore, the Translational Health Science and Technology Institute in Delhi, with Apollo hospitals locally. We also work with municipal agencies such as the Surat Municipal Corporation, which is interested in dengue and how mosquito spreads. We've organized multiple schools and workshops over here as well as elsewhere. And as a group in India who works on the modeling of disease, we are fairly unique. We are respected. We are known for our work in this area. And there is certainly a lot of interest from people outside and talking to us and trying to find out how is it that we can help looking at their data and making predictions for what might be the best way to go forward. So just to summarize, we started off with strengthening research impact, raising IMSC's profiles, meetings and workshop visitor programs. So much of the proposals that have been are really in the line of how do we strengthen what we already do, how do we raise our profile, how do we make more impact in the world outside. And as I will stress again, it's competition that is key to a lot of what this is. Here are the pictures that define the emerging areas that I talked about, the quantum computation, the material science, the pulsar, the toxicology, the networks for econophysics and data science, as well as the infectious disease modeling. So this is just a snapshot of what it is that, how we view the future, and we view it in multiple ways. One is just how do we do better what we do already now, and how do we respond to the wider world around us, how do we respond to national priorities, how do we respond to what it is that would be good for us to do as a country, how do we contribute maximally to that particular line. And with that that's all I have. Thank you.
So it's about our work in education and science communication. Of course, the question is how can the research institute contribute to education, and should a research institute contribute to education? And I think I want to address what we have been doing on that. How much effort should we be putting into this? There are several heads of involvement. One is in curriculum development, and I think people here have been involved in school level and undergraduate level and postgraduate level as well. And then some contribution to national outreach efforts like Circ schools, ATM schools, MTTS, which is a very successful math program, and recently started physics, similar physics program, NPTEL, Inspire. So many of us have been contributing to these. And then also assistance to outreach efforts by other institutions, then outreach activities directly organized by IMSC, and IMSC's own YouTube channel, which was mentioned earlier, and really hundreds of hours of lecture videos that are accessed widely by people. And then science and math popularization, for example, in Science magazine. So there is involvement in very wide variety of things, and even areas like adult literacy education. Now, specifically the outreach programs organized by IMSC, I think this is something that I want to emphasize as something unique to IMSC, and I would in fact like to single out the math group in IMSC as doing extraordinary work, which is quite unique in the country, where mathematicians largely have very little connection with school teachers or school children and so on, and here is something regularly done. There is a regular summer student program which is run by most educational research institutes in the country. But then there are special programs, for instance, during IMSC Golden Jubilee year, Ramanujan year, 125th year, annual meeting of the IAS at Chennai, etc. Then there is Open Day, which IMSC organizes. Then Indian Women in Mathematics, there are these conferences that have taken place here. And then you have specific programs targeted at school students, annual basis, school teachers, separately for high school teachers, higher secondary teachers, college students, college teachers. We even had a program specifically for teachers of Polytechnic, because we live in this campus with Polytechnic institutions. And then for research level students. Of course, research level students, there's a large number of programs that happen, but I wanted to point out. And then there are these programs for the public at large. So, as part of, and then Science at the Sabha, where we've been doing this program at the Music Academy. I'll mention that later. So, again, to follow Vijay's tradition, to give one example of each of these. Maths example, facets. This is a 2-day program for college students that attempts to showcase current research, and it's set in a specific calendar. And also, in fact, college students and teachers have got used to a program like this, and people write to us about it. Sponsored by national academies earlier. Participation exceeds 200, and it can be easily more. It's just that our capacity is only so much. And there is a very popular session where we talk about careers in mathematics and discuss that. And this is something that undergraduate students are very much into. And similar programs go on for high school students, and then for college teachers, high school teachers. Then in physics example, there is this very famous math MTTS program that has been going on for a couple of decades in mathematics. I recently started one is in physics, inspired by the same one, and it's supported by IMSC both in spirit and financially as well. And important thing, for instance, is that students design their own experiments, for instance, to determine. This is so we talk about experimentation, but students have very little experience of experimentation as such, and the PTTS program emphasizes that in IMSC. And they actually design the experiment and then implement it, building their own apparatus. So, and they're given a specific budget and within which they have to do it, and I think it's likely to be funded by Infosys. I don't know what has happened to the funding. TCS example, the Theoretical Computer Science group has been doing these courses for college teachers, and periodic refresher and foundation courses for teachers from colleges and universities, conducted by IMSC faculty, typically hosted at some college or university, and IMSC provides funds and takes care of the academic program. There have been even ones that have been month-long, even for teachers from South Asia, ones we conducted here. And now, this is for a felt need, because computer science departments opened in this country in a large scale, but foundations is something that is extremely weak, and there's a felt need, and people come and respond to this in significant numbers. And then there's a lot of work in curriculum development, and the people are members in boards of studies, and in fact involvement in UGC model curriculum. Here is an example of a course where the entire curriculum discussion took place for a month-long course at IMSC, and that curriculum is now used in several NITs and IITs and IIITs as well. And now, what about in schools? What can these kind of high-level researchers do? And there are critical review of textbooks that we have participated in, inspirational lectures for school children that happens regularly, and then design of math and science material, activities, games, projects and experiments, extensive participation in the boards of NCERT and SSA, and right now, in fact, in the curriculum revision that's going on in the state. Then in science popularization, well, there is an enviable track record at IMSC. Science at the Sabha now attracts nearly 1,000 strong audience, and it's something I think Chennai should be proud of, because this is research science being talked about. And IMSC Open Day is now immensely popular, and we get contacts from schools asking, when we were late in conducting it, there were many knocking on our doors and asking why are we not doing it. And popular science activities not only in schools and colleges in Chennai, but also in the districts and other states. ENO has taken up outreach, in fact, pretty much even to villages. There are publications. We have members publishing regularly in periodicals and publishing books in English and in Tamil quite regularly. And there is significant presence at the National Children's Science Congress. And IMSC has in fact supported some Children's Science Congress activities regularly. So IMSC has to sum up, IMSC has the potential to set up and nurture a resource center for education in mathematics and the sciences. And when I say education, I mean at all levels of education, school and college. And intervention can be in the framing of curriculum and syllabus, where we have experience. We have experience in almost all of these things: guidance and teacher education, mentorship for teachers and students, beyond the textbook material, focus on senior secondary and undergraduate levels, where actually there is very little. In fact, much of education, research in mathematics and science in the country almost exclusively focuses on the elementary stage and very little on the secondary and undergraduate levels. And this is something that we can contribute extensively, and there is a felt need in the country, and there is a big space for contribution. And IMSC as a platform for science communication, I want to emphasize again, communicating the relevance and excitement of research in a field to the general public is something that's very important, and we can take some pride in having been doing quite a bit of that. And in attracting young talent to the basic sciences, use of new technologies to expand reach, and like we talked about YouTube channel, overall our record in that has not been very good, and we need to go a long way in this. A conscious and systematic attempt to increase our visibility among students and the educated public, and this is again very important because in general among the public, people know about IITs, but research institutes are not known at all, and that something is going on. Some very interesting research in mathematics is possible. It's not something that children know very well, and so there is a way to go. I would say a formal acknowledgement of a role that IMSC and other institutions can play in education at all levels is important. Interaction between teachers and educators is healthy for both, between researchers and educators. Creating and expanding avenues for research interaction is to be taken seriously. Resource creation for school education is a national and developmental priority, and researchers can help immensely in this. And this is an avenue that India has not explored sufficiently, and this is something that we can do a lot. Now the new technologies are hijacked by low content, and we can and should help in content creation in this. Scientists can, and I think, have to play an important role. And whatever little that we have seen from IMSC is already making some impact out there, and this is something that we can do a lot. So here are some pictures from some of these programs. I just wanted to show this unusual thing of children hanging around in research institutes, and these experiments are immensely popular by now. And this is a fold scope which generated so much excitement all around the campus last year. And so that elephant's toothpaste is now almost associated with IMSC. I mean, you say Google elephant's toothpaste on Google, what you get are IMSC pictures. This is something in a corporation school. That's what I want to know. So, okay. Thank you.
First of all, I must apologize for being delayed, and normally people say that no, airlines is responsible, but I cannot do that. I would say that I am responsible and bad planning is behind it. The reason is that I have been here too long in Tamil Nadu and this part of your city. That is, we used to stay in Kalpakam, and before that in Nilangarai. And I was telling Professor Arvind that at this road by which we are coming, I must have driven myself 1,000 times on that road. It is a very long experience. But I have forgotten that how much time it takes to reach from airport to your place. So that was, it took about an hour, whereas it used to be about 10 minutes when I was driving those days. So and it was mid part of my career I have been here, and now of course after that I have been to when I went back to Bombay in 2005, that every week I used to be here for 3 days. So like that almost up to 2010 I was mostly part of here, as well as of course Tarapur is the other place where we had a lot of things happening at that time. Bombay was my residence, so I used to meet my wife when I was in Bombay. That was the idea. And I would say I have a complaint that Professor Arvind has not given me this special coffee, which I only smelled when I was going to that side. So these are the, now when I was coming this side, today morning in the aircraft, I was thinking why I'm going there. So one of the reason is, apart from meeting all of you, one of the reason is that I would be able to get a sambar rasam at this part of the world. So that's how you change. And with that kind of introduction, and this your place, this institute, we had been visiting. Of course, I had nothing to do with mathematics, but we used to come here to be on our guest house. Some function will be there which we'll attend here. That's the way our connection was. My connection was there with this place. And yesterday when I was telling my wife, she says, where you are going? I said, Math science. Oh, math science. Because you know, you will not know. Our Koteshwar Rao, Venkatraman, they are the people. I don't know how many of you know them. They were the people. They used to talk about this many a times, or most of the time. So that is how we came to know. Then we started visiting. So I am, although most of you may be seeing me for the first time, but I am not a stranger to this place, your campus. Okay, with that, I think what I will go do this, because this whatever work you do now, I have indirect connection, and it was very good that Professor Arvind invited me to once. I was thinking what I would do going there, what I would understand out of mathematics, because I don't know much of mathematics, and but I thought it was, right now after going through your presentation, it is, I thought it was interesting, and many things are happening, and some, I think, mid-course correction has to be there. Well, my background is mostly Navy, and because of ships, when it is taking a course, it has to go on doing corrections. Unless you do the correction, you will go to a wrong direction. So that's exactly what probably needs to be done. But what I am telling is not my views, but is the view of the government. Government means not, we are not government, means government is people who are above us. Okay, then firstly, let me tell you that what is the way now science is being looked after by the present formation at high level. See, they feel that they have invested a lot of money, and the money amount is about 30 to 40,000 crores per year now. This has been going on. The math science is 50 years old, and is not math science since after independence. You will see how it was happening. This has become a lot of money if you multiply over all these years, because it's not 40,000 crores. It was not that much that period of time starting. This was, maybe it would have been only 100 crores. But if you multiply the valuation wise, it is today's value is that much. Now government's question is that what you have given out of that. You means what we have given to them. This question is very difficult to answer. When we do, when we talk to them, because they will not understand your string theory or computational biology. These things they will not understand. You have to tell them in a language understandable by the public. This is the gap that we have between ourselves and science. And also you have to all accept the fact, and which you must be hearing everywhere in the country. Everywhere there is a discussion, which I am doing. It has become everybody's pet topic to say that we are not doing well in science. Again, that is not correct. That it is our responsibility to correct that situation. There are two ways. One is the impression is wrong, and another one, whatever part of the impression is right, we have to set the things right. So look from that angle. And whatever I tell you, don't take it any other. I am not criticizing you. I am criticizing myself, because as I can see, all of you are much younger than myself, and this is my 44th year in this department, and I had been doing only this, whatever I am doing now. So with that background, so I tell you little more things. Now one is, see, whatever work first we are doing, that recognition. How do we get recognition? What is recognition? You get some small award that nobody thinks about it. But just as we are traveling together, we are discussing, okay, Bhatnagar award, people have got from elsewhere. Why nobody has got from this place? It could have been easily that every 3-4 years at least, you are covering at least 3 topics. And everywhere some Bhatnagar award should be there. Why it is not there? I am telling at the minimum level. No, I am not telling that why you have not got Nobel Prize. No, you just bring it to some level which is not getting Nobel Prize. There are many reasons, and that is only your quality of work is not the only reason, but there are many other reasons. But whereas getting Bhatnagar award is easy for particularly younger people. So you should recommend more of your students, more of your younger faculty members for this award. So this is one of the thing how people look at outside, I will say. Other thing is that we are just now with the first lecture, Vijay was telling about Kac-Mondi algebra, Kac-Mondi algebra, and this type of thing. But why it is not Vijay and Rahul algebra? Something would have been there. Why it is not there? Why it is not in the name of Indian scientists? That is the difference. That is what people look like. Okay, you talk so many foreigners, but why it is not Indian? Why there are no Ramanujams now? There should be, even if you say he was too great a person for us to come to that level, okay, leave that. Why not somewhere little lower level? This is what is the problem. This is what we are not able to convey to them. Then I have got some theories on why and how it is not happening, and what will happen. It can happen. One is, we are not having many big projects which are Indian big projects. There is a difference between CERN and INO. See, in spite of those who probably many of you know here, in spite of so much of effort, we could not bring up INO. It's a problem of our country. We could not bring up INO here, and at least if it was even the point of time government got sanctioned, today it would have been, project would have been half the way if these problems are not created. But tomorrow, supposing INO project is there, you will see that every year we have something to report, not one but many, which is automatically becomes international standard, because others are not reporting. Some of you may be aware of that MES telescope which is coming up in Ladakh. Now that is what it will be. Tomorrow we will, like NASA is predicting so many things, or saying that they have found so many things, we will start doing it, because so much of data will be connected, and that is one of the best placed telescope. So it will happen. So big projects are important, but Indian big projects are important. Now what is the difference between even LIGO, what is another big project which is there, which I am involved, that will come up in India someday. So again, at least even if it is a original American one, but we will be able reporting discovery. But you see, Higgs boson, don't misunderstand me, but see the difference. A paper comes out publishing the discovery, 1,000 people are involved, 1,000 names are there, and then out of that 60 are Indians. But in a paper where 1,000 names are there, how much is your contribution? It has to be small. It cannot be big. Or even CERN, not CERN, what was that? LIGO that was being talked about, LIGO, gravitational wave discovery. Out of 1,000 people, only 37 are Indian. But 37 are Indian, all right, but you cannot say anybody has made any big contribution in that. You will not be able to expect, okay, we are there, so many good things have happened, and probably, I don't know, anybody is here from that, in those 37, LIGO, no. But CERN it is there, no? Higgs boson it is there, no? Some of you are there in Higgs boson. And you could have been easily there. But my point is that even being there does not bring us that much credential. But had it been in INO, if it is in MES, if it is in LIGO, you will get a different form of credit. This is the difference you must understand. But we always prefer to go to CERN and do some work. Or we always prefer to do, say, what is that formula project on neutrino? We would prefer to go and do work over there. But that doesn't bring us credit. Credit, if you do it Indian, it will be much more accepted or by the people of India. Like whatever I have heard in the presentation, this modeling of infectious diseases, this looks most attractive to me, because to get credit for us and also to do something for the nation. Why? Because this is a national requirement. This is a requirement by the society. This is a requirement for the poor people, and then if you can get a large part of the project, it may not be, everything will not be there with you, but if you can get a large part of the project, that will bring us much more credibility than others. Like say genome mapping project. Okay, that's what every individual do is small, but whole thing is very big. So that is why what I'm trying to say is that being a part of a big project, big credibility, much faster, much more easily. Unfortunately, in India, we have not been able to bring up those projects, but it will come someday. And if it comes, you will see that there is a total change in whatever scenario within our country. Okay, then two other. This is what is recognition part, and other thing is there. That we do a lot of work. I am not talking about your institution. In general, in DA, we do a lot of work, but small development takes place. But do you find anything in the country which you can say that it has been developed by atomic energy scientists? No. But there are many. Why it is not there? Why you don't see? Is only those people who are involved, they know something has been done. That is because it has not come as a product for the masses. Today itself I was saying that something on teletherapy machine, whatever has been developed at BARC, they are getting some publicity on this because some technology has been transferred to industry. 3 people have taken and they are marketing the product. Some recognition is coming. So if you have to get recognition, one thing that is necessary that your product should go to industry. Your development should go to industry. Then only it will reach masses. You cannot take it to masses. Whatever you do, it is not scientists' work to take the discoveries or take the product developed to the masses. You cannot do that. And other thing that I want to talk to, these autonomous bodies have got into a lot of problem in the area of the government, in the eyes of the government, because there are more than 600 autonomous institutions. 60,000 crores has been invested on them, and government thinks that no return has come. And that is why, in between, at least you must have heard that when the pay commission came, that pay commission rise, they say that 30% of the money you should earn and then only it will. It has become our full-time job to fight with the government to get the money for you so that you don't do that. So, you see, these things are changing. And I have my own analysis over these 42 years, we can look back. 44 years I can look back. What I find is that we have one stage that pre-independence, it was the starting phase, very difficult phase. Practically nothing was there, very few things were there. That's how, and there it started. The starting phase was good. Then we have expanded. Expansion was the next phase. Yes, we have done expansion. Today 600 or 800 autonomous institutions are there. Everybody is doing work on everything. But what we have not done and what is requirement of today is consolidation. We have not looked into this aspect of what this question when you ask, you will find that very little has been done. Although your type of institution, finance involved is not much because you don't have big experimental facilities. But those who have big experimental facilities, they spend much more. But what is the outcome? It is same. It is not much. So that is why maybe whatever future things you are taking, and what you do is you please give me this presentation. You send me in terms of a mail. Let me have a look whenever I have time. No, not because is this much because I cannot read all for one proposal. Anyway, some 1,000 pages land on my table every day to read. So that is why I am saying while traveling, maybe today is not possible, but whenever it is possible to give it while traveling, I pick up. Because most of the time I travel. There is the other problem. Okay, so with this autonomous bodies problem is over. Now let us see what is it can come as a solution to our present problems that we are getting into. One of the things that will happen is that we will not get any more extra money. Whatever we are getting, it will remain at that level. That means very little increase will be there. That means we have to manage within this money, and also if we have to really get recognized, we have to excel. So with that money, you should get do more work, more quality output, and get into this way. Please see this quality output does not mean producing papers. There are other things which I told you. And producing paper has been somehow Indian science has got oriented towards producing paper. How many papers you have produced is more important than what is your contribution. So okay, you try to add value by saying it is a high impact journal and things like that, but it doesn't. It is not all journals are not Nature. How many publications you have in Nature? That is the question. If you ask, it is nil or very little, one or two here and there, exceptional cases. So let us say that one thing that we do is we try to focus on some areas, and this is one of the biggest problem, and particularly I see in DAE. DAE has spread too thin every area. That is why we can be neglected. If you have some peaks, say you are doing 100 activities, but at least 5 of them, 10 of them peaks, goes to much higher level, then it gives you much more back, much more recognition. Then you cannot be ignored. But instead of that, you add another 50 more areas of work, again you will remain in this level. Nobody bothers about it. That's the basic difference we have. So let us focus on some things. Say you whatever I saw, whatever I could understand, if that at least some 30-40 areas have been proposed as future work. So instead of doing that, maybe take up 4 or 5 areas, focus on that, then things will move faster and probably quality will be better. This is the way I look at it, and I am trying to do it everywhere on these lines only. And I only have one more point, is that, so I have talked long enough, no feedback. But anyway, this whatever you are doing on education, now more recognized education research institution in our country is Homi Bhabha Science Center at Bombay. So government also has formed committee of secretaries, etc., to look into why science is going down, etc., etc. So we have given them many promise. I will maybe sometime else I will speak about it. But what is there is, we have taken up one project, Vigyan Pratibha. There some students have to be channelized into science, and it is not the projects of this type, because when I was in school, that time also some similar programs were there, but it has not paid off much. So what we have been analyzing what was the fault with that. Based on that, what we have decided is to take up 2-3 is about 20 each school, some 2 or 3 and 10 schools, say 20 from each school, and then divide it into some 4, 5, 10 regions in the country with DAE, and then everywhere they will pick up some 20 students every year from 8-10 schools, and then educate them for 10 years, not educate them, mentor them for 10 years, starting from 8th standard to PhD out, and then job. This is one plan which we are working, and in this this year we have already done it. Homi Bhabha Science Center in one Western India, and then SINP at Eastern India, they have started this program in a small way. Because Homi Bhabha Science Center anyway had all this facility already with them, and some of the slides I was seeing that they were the way you are trying to teach the children. Homi Bhabha Science Center have got a systematic method for that. Also, you may be having that. I do not know the details. So first year we have involved those two, and by March or beginning of next financial year, I would like to involve 2 institutions. One is yours, and another one is HRI at Allahabad. So I will get it with more details, and you can talk to Mr. Subramaniam, who is HBCS director. And then you can pursue this, and we will maybe we'll have a meeting at Bombay with all this for the next 2 institutions that are to be taken up. We'll have a SINP and HBCS, yourself, and HRI somebody will call, maybe one more institution from IOP or somebody like that. So next year we can start 3 or 4. So then it will go on, and then what we have to see now, what is success in this? This you must remember, which is not taken as a success. See, IIT IIT, why IIT was formed? We get good engineers who will serve the country. But how many IITians serve the country? Is only a passport for going to US. My batch, I am not from IIT, I am from another college in VJTI Bombay. We are 72 students, only I did not apply. All other 71 applied and 67 landed in US. So what is the point in government funding all those colleges? So it is not that. Your success is in this, that how many are joining back in our IMSC or HRI or SINP or VRC like that. That is what is, and we have to also create job opportunities. That's the other point. That they themselves say that no, where I would go if I don't go to US. So then the question is that then we have to create opportunities for them. So this is a big program. We are only just in the beginning of it. Next year we have to expand. So that's why I'm requesting you, let us start this process, and this would be also a very big contribution from our side if we succeed. And next year onwards we will start getting money for this also from the government separately. Okay, thank you. And maybe one or two questions. Okay.
One small question.
Yes. Yeah, it is there. See, what happens in many projects, total money will be given is constant, but you can always divert some of the funds to the new project, that new areas which is the project. Then that is a very big flexibility. Once we are allowed that, this is a very big flexibility. This is what we are trying for. No, it will continue. See, this growth rate, etc., whatever you are saying, the growth rate will, if it continues, or maybe little less than that, whatever is being claimed is continuing, then we will have a position of money. And these governments, it's quite obvious that okay, make more toilets rather than invest in science. So anyway, there is nothing wrong in it. That's also correct. But we have to explain that no money is required for. And second part is that whatever money we have got, we are getting. Are we utilizing it properly? Are we giving proportionate output? Which, if you think very seriously, you will find the answer is no. So that is the first. Let us improve from our side, and then start asking for more money. But Mr. Modi in the Science Congress, is here only, last Science Congress was in Chennai only, So there he has said that we will, Tirupati. Okay. So he has said that we will do everything possible to make India the third best country in the world in terms of science and technology. So those things people have told him, but we have to help ourselves. Others will not help us. This is the difference. So if you excel, then automatically things will go. And you means we. If we excel, everything will move well. Okay, thank you.